Hi, welcome to a new module. This is about the Integrated Design Project, which is the final year courses for civil engineering programs. This course is typically carried out in 2 semesters, same like the final year projects. This Integrated Design Project is different from the final year projects, as it focuses on the practical designs, whereas the final year project focus more on the research studies. These are the overview of this course. This course will be entirely projects or practical design, and it is normally carried out in groups, maximum 5 members in a group. Basically, there will be supervisions by the lecturers with the professional status, such as professional engineers with practicing certificate and the professional engineers. In the integrated design project, all the fields related to civil engineering shall be covered. Projects from the industry shall be given for the students to work out the engineering solutions. This serves as the inductions to the students before graduating. It also allowed the students to recall and apply the knowledge learned throughout the 4 years engineering programs in the respective tasks and the projects given. There will be a lot of exposures to the industrial practices, and the expectations and requirements shall be in accordance to the industrial practices. Because of this, students will need to have a minimum amount of credit hours to be eligible to register for the course Integrated Design Projects. Different universities conduct the Integrated Design Project differently, but the principles are the same. It gives a thorough coverage of all the topics and field of studies learned throughout the 4 years program by going through a series of projects. The students find the linkage between different stages and different types of projects. In this module, we have Integrated Design Project 1 and Integrated Design Project 2. The Integrated Design Project 1 shall be carried out in the first semester, while the Integrated Design Project 2 shall be carried out in the second semester. The course here is designed in the manner that all these are referring to the same project in order to demonstrate the linkage between different parts of the projects. The integrated design project is referring to the planning and design stage, and the students are required to produce the project feasibility study report, environmental impact assessment, soil investigation report, engineering plans for road, drain, slope, retaining walls, structural plan for buildings, water reticulation plans. As for the Integrated Design Project 2, there will be bills of quantity, master work program, tender and contract document, site safety, health planning report, construction quality assurance plans, and also project cash flow and revenue. These are related to the procurement, implementations, and management of the project. By looking at the scope here, you can imagine the amount of the work to be carried out by the students, and this shall be carried out in groups. Normally, we will require the students to have a group leaders leading and managing the projects throughout the entire semesters. The students are given one single project, asking them to produce all this. And then later in the second semester, based on whatever available as acquired from the first semester, they will need to work out the followings. As different parts of the project, they are interrelated. The specifications or the design, as well as the amendment on certain part, shall eventually bring to implications to the following parts. For example, based on the information acquired from the EIA and also SI report, shall eventually govern the designs of the engineering plan and structural plans. And based on the design, the bill of quantities are produced, and so on and so forth. In terms of the teaching and learning activities, this course will be entirely project supervisions. There will be site visit and also field studies. Students are also required to visit to the local authorities in order to acquire the submissions requirements, guidelines, and checking criteria. There will be desk studies and also laboratory tests, some lectures, group discussions and meeting, and then there will be interim presentations and progress monitoring. As you can see here, we are not only looking into the technical aspects, we are also simulating and giving the students to experience how to manage a project and also monitor the progress. In terms of the assessment, normally there will be project supervisor evaluations. These are related to the practical skills, soft skills, attitude, and the assessment will be based on the performance of the students throughout the semester as evaluated from their interim presentations, group discussions and meetings. And then there will be project report. The assessment mainly focus on the technical knowledge and skills. Lastly, there will be oral presentations. In the oral presentations, normally the external examiners shall be invited, and the invited external examiners are the practicing engineers having vast experience in the industry. The purpose here is for the knowledge transfer, getting the inputs from the practicing engineers, which at the same time having them to identify the limitations and the weaknesses in terms of the design solutions, technical knowledge and skills. At the same time, we use this platform to promote our students to the local industries. As for the references, there will be various types of standards, guidelines from various authorities and departments, manuals for the software, equipments and tools, and the samples for the industrial works. This is a brief overview of the integrated design project. Now the question here is how this module is delivered. I will consider this as the knowledge sharing for whatever that I know in the various scopes here, and probably some recommendations and guidelines for the students who are undergoing the integrated design projects, knowing that most of the students when come to the integrated design project, many are confused, not knowing where to start, how it goes, and what are the expectations. The mechanism here, it will be more towards giving you guidance and directions and establishing some basic understanding and knowledge for you to kickstart your project. Another purpose here is for the fresh graduate students who are about to enter the industry, facing the challenge in the real engineering world. At least this serves some guidance to you and boosts your confidence in undertaking the assignments and tasks in the real life. Now let us talk about the requirements for the integrated design project. As you know, for the students undertaking this course, there will be assessment. There will also be grading, giving you an idea the levels of understanding and achievement after completing the course. The assessment can vary significantly among the institutions. Therefore, we will not talk about the assessment rubrics or requirements. Instead, we will go back to the roots where the institutions will design the assessment on the basis of the graduate attribute profile as specified by the Washington Accord. Since this course provides an exclusive summary for the entire civil engineering program, by right, this can be a really good tool for your institutions to assess whether you are well equipped with the relevant graduate attributes. In Malaysia, we are accredited under the Engineering Accreditation Council, and this is designed in accordance to the Washington Accord so that our graduate can also practice engineering in the other countries signatory to the Washington Accord. This requirement shall be universal to all these countries, having the same levels or expectations and requirements in terms of the qualities of the graduates produced. Now they outline the graduate attributes from WA1 to WA11. 11 attributes of graduates having the sufficient quality as described in the statements here. WA1 is about the engineering knowledge, having the ability to apply the knowledge in order to develop solutions to complex engineering problems. This knowledge is not limited to only civil engineering. This involves the synthesizing of various fields of knowledge, including the mathematics, natural science, computing, engineering fundamentals, and engineering specializations. Especially when it comes to the assessments of the project report and also during the oral presentations, we are able to observe and evaluate the engineering knowledge possessed by the students and their ability to apply those knowledge. Second, it will be problem analysis, having the ability to analyze complex engineering problems using the first principles and taking into the considerations for the sustainable development. This sustainable development here is newly added to the graduate attributes. Previously, the focus it will be on analyzing the complex engineering problems. Now there are additional requirements, not only having the ability to analyze the problem, we will need to have considerations in terms of the sustainable development. And then next, it will be design and develop the solutions. And there shall be elements of sustainable development, considerations of the environmental issues, cultural and societal issues. Next is the investigations. Conducting the investigations for the complex engineering problems. Among the relevant, this includes the site visit, field studies, desk study, laboratory tests. Next is about the tool usage. In order to come up with the design, for example, engineering plans and structural plans, there shall be softwares such as AutoCAD, Eng-aim design, and other analysis and modeling software. In terms of the soil investigations, EIA, there shall be field tests and lab tests. This will involve the tools and equipments Next, there will be the engineers and the work. In the design, carries the responsibility for sustainable development. Ethics, to reflect the professionalism, professional ethics, and then individual and collaborative teamwork. As this project is carried out in a group, there are normally evaluations for the students as an individual or as a leader in the group in order to carry out the task. We are also looking into the communications, having the ability to communicate effectively among the group members, communicate with local authorities, communicate with the supervisors, doing the presentations, producing reports, and communicate with practicing engineers in the industry. Next, there will be project management and finance. We shall evaluate how the students execute, manage and monitor the project, how they coordinate among the group members, subdivide the tasks, do proper planning, control and monitoring the progress. Sometimes we require the students to take down meeting minutes for them to experience formal meetings and learn how to produce meeting minutes. As for the finance part, there are bills of quantities, tender and contract document, as well as project cash flow and revenues. There will also be project feasibility studies, which focus more on the financial feasibility. And lastly, there will be lifelong learning in order to encourage the critical thinkings and continuous learning among the students related to the latest technology as well as the practices in the industries. As you can see from the graduate attribute profiles, there are complex engineering problems, complex engineering activities. In fact, we have a series of definitions for the complex engineering problems and also complex engineering activities. These are meant for the lecturers who design for the integrated design project. As far as the students is concerned, you know that the project here, they are complex in nature, and throughout the project requires a lot of communications between the students and various parties. The purposes communicating with those parties vary significantly due to the role and the functions of the parties. Therefore, the entire integrated design project is normally designed also on the basis of the complex engineering activities.